Have you ever wondered what gives the unique aroma to your favorite spices like cinnamon and cloves? Or what makes the resin on pine trees so sticky? These questions might seem unrelated, but they both lead us to the intriguing world of terpenoids and resins. Terpenoids, also known as isoprenoids, are a vast and diverse class of organic compounds produced primarily by a variety of plants, but also by some insects. They're responsible for the enticing scents of many herbs and spices, and they also play crucial roles in plant defense and communication. On the other hand, resins are sticky substances that plants produce, often seen oozing from pine trees. They contain mixtures of many different compounds, including terpenoids, and have a wide range of uses from varnishes to adhesives. So next time you're enjoying the aroma of your favorite spice or observing the sticky resin on a tree, remember? Indeed, these fascinating compounds are none other than terpenoids and resins, the hidden gems of biochemistry. Now that we've piqued your curiosity, let's dive deeper into the world of terpenoids. Terpenoids are a diverse class of natural products, and their classification is largely based on the number of isoprene units they contain. Isoprene, a 5-carbon compound, is the fundamental building block of all terpenoids. Let's start with the smallest of the lot, the monoterpenes. As the name suggests, monoterpenes consist of just 2 isoprene units, making them 10-carbon compounds. They're responsible for the delightful fragrances of many essential oils. Think of the refreshing scent of lavender or the invigorating aroma of peppermint, and you're thinking monoterpenes. Next up, we have sesquiterpenes. These 15-carbon compounds are composed of 3 isoprene units. They are often found in the plant kingdom and contribute to the unique scents of many herbs and spices. If you've ever wondered what gives ginger its distinctive aroma, look no further than the sesquiterpenes. Diterpenes, with 20 carbons and 4 isoprene units, are next in line. These terpenoids have a variety of roles in nature, from serving as plant defense compounds to acting as hormones in insects. The bitter taste in your morning cup of coffee? That's the work of diterpenes. Triterpenes, bearing 30 carbons and 6 isoprene units, are precursors to steroids and sterols. They're vital to life as we know it, contributing to the structure of cell membranes and serving as key components in many biological processes. Lastly, we have tetraterpenes. These 40-carbon compounds, composed of 8 isoprene units, include some of the most visually striking molecules in nature, such as the vibrant pigments found in tomatoes and carrots. So, from the refreshing scent of citrus fruits to the bitter taste of beer, terpenoids contribute to some of the most sensory experiences. Their diversity and ubiquity make them a fascinating subject of study. Stay tuned as we delve deeper into the world of terpenoids and resins in the coming scenes. Moving on from terpenoids, let's explore the sticky world of resins. Resins are solid or semi-solid substances that plants produce, mostly conifers, as a protective response to injury. However, resins are not exclusive to plants. They can also be found in some insects and can be synthetically made. Firstly, we have natural resins, which can be further classified into plant resins and insect resins. Plant resins, like pine or copal, are often thick, sticky substances that harden over time. They serve as a plant's natural defense against insects and disease. On the other hand, insect resins like shellac are produced by certain insects as a protective covering for their larvae. Then we have the fascinating world of synthetic resins, which are man-made and designed to mimic the properties of natural resins. They are usually divided into 2 groups: thermosetting resins and thermoplastic resins. Thermosetting resins, like epoxy, harden irreversibly once heated and shaped. They are used in applications requiring high heat resistance. Thermoplastic resins, on the other hand, can be heated and reshaped multiple times, making them ideal for recyclable plastics. Resins can also be classified according to their chemical composition. Some common types include polyurethane resins, used in foam mattresses and car seats, polyester resins, used in boat hulls and shower stalls, and vinyl ester resins, used in pipes and industrial tanks. These diverse properties of resins make them incredibly useful across various industries. Artists use resins to create glossy, protective finishes on their works. Electronics manufacturers use them to insulate and protect sensitive components. Even in the medical field, resins play a role in creating certain types of bandages and wound dressings. Just as terpenoids, resins too play a crucial role in our lives, from the varnish on your furniture to the adhesive on your Band-Aid. Now that we've classified terpenoids and resins, let's delve into the chemistry behind these compounds. Terpenoids, also known as isoprenoids, are a large and diverse class of naturally occurring organic chemicals derived from 5-carbon isoprene units assembled in thousands of ways. Most often, the term terpenoid is used to denote compounds that have been modified with functional groups or rearranged. The basic molecular formulas of terpenoids are multiples of C5H8, reflecting their origin from isoprene units. Their structure is a fascinating labyrinth of carbon rings and chains, adorned with various functional groups such as alcohols, aldehydes, ketones, and esters. This diversity gives rise to an array of properties that make terpenoids useful in a wide range of applications, from perfumery and pharmacy to biofuels. Now, onto the biogenesis of terpenoids. It's a fascinating journey that begins with the simple molecule, isoprene. In plants, isoprene is synthesized from acetyl-CoA in the mevalonate pathway. The process involves a series of enzymatic reactions that create the basic terpene skeleton, which can then be modified to create the vast array of terpenoids we see in nature. Resins, on the other hand, are complex mixtures of compounds, predominantly terpenoids, but they may also contain other organics and inorganics. They are semi-solid or solid materials that are often amorphous and are produced by many plants, particularly coniferous trees. Resins are typically insoluble in water, but soluble in alcohol and other organic solvents. The chemistry of resins is as diverse as the plants that produce them, with their structures varying widely depending on the species. However, the common thread is the presence of terpenoid compounds, which give resins their characteristic properties, such as their stickiness, hardness, and ability to dissolve in organic solvents. The biogenesis of resins in plants is a complex process and is often a response to injury. It involves the conversion of glucose into resin acids, which are then polymerized to form the resin. The exact steps and compounds involved can vary greatly between different species of plants, reflecting the diversity of resins in nature. Finally, let's touch upon the analysis of terpenoids and resins. Qualitative analysis usually involves techniques such as mass spectrometry, infrared spectroscopy, and nuclear magnetic resonance spectroscopy. Quantitative analysis, on the other hand, often relies on gas or liquid chromatography, which can separate the individual components of a complex mixture and measure their concentrations. So, the chemistry of terpenoids and resins is not only fascinating, but also holds the key to their diverse properties and uses. As we reach the end of our journey in the world of terpenoids and resins, let's recap what we've learned. We started off by defining terpenoids and resins. Terpenoids, also known as isoprenoids, are a large class of naturally occurring organic compounds produced primarily by plants. They're responsible for the fragrant scent of many herbs and spices, and they also play a crucial role in plant defenses. Resins, on the other hand, are solid or highly viscous substances of plant or synthetic origin with no fixed melting point. They are primarily composed of terpenes and are known for their adhesive and sealing properties. We then dove into the classification of these fascinating compounds. Terpenoids are classified based on the number of isoprene units they contain, with monoterpenes, sesquiterpenes, diterpenes, and triterpenes being the main classes. Resins, meanwhile, can be classified as natural or synthetic, with the former further divided into hard or soft, oleoresins, gum resins, and balsams. We also explored the unique properties of terpenoids and resins. Terpenoids are characterized by their aromatic qualities and their ability to participate in a wide range of biological activities. Resins are noted for their high viscosity, adhesive properties, and resistance to water. Next, we delved into the chemistry and biogenesis of these compounds. Terpenoids are derived from the 5-carbon compound isoprene, and their synthesis involves a series of enzymatic transformations. Resins, on the other hand, are formed in specialized plant cells and are often exuded in response to injury. By now, you should have a firm grasp of the basics of terpenoids and resins, including their definition, classification, properties, and chemistry. But remember, This is just the tip of the iceberg. The world of terpenoids and resins is vast and ever-expanding, with new discoveries and applications being made all the time. With this newfound knowledge, you can now appreciate the science behind the scents, flavors, and materials you encounter daily. Subscribe for more because you won't find me later.